Good morning. Lesson 3-3, divide whole numbers by fractions. Yes, this is good. Okay, so we got some things to learn here. Apply what I previously learned about multiplication, division, and operations on multi-digit numbers to divide whole numbers by fractions. So we got to remember a couple things. First, what's a reciprocal? Here's the technical answer, okay? Two numbers whose product is 1 are called multiplicative inverses or reciprocals. The inverse property of multiplication states that the product of a number and its multiplicative inverse is 1. Okay, here's what that means. The reciprocal of 2 over 3 is 3 over 2. You flip it over. Bink. Flip. An inverse is you invert those numbers. You just flip them, okay? Ooh, here's some cool stuff. A over B times B over A equals 1. Well, here's why. A times B is A times B, and B times A is B times A. And anything divided by its own self is 1. That's why it works. But we can do it this way, too. What's 2 times 3? 2 times 3 is 6. What's 3 times 2? 6. What's 6 divided by 6? 1. Right? So the inverse, take your fraction, flip it over. Next thing, any whole number, 27, written as a fraction, is itself over 1. How does that work, Miss D? Well, what's 27 divided by 1? It's 27. Tricky. Okay, let's try this. Find the reciprocal of 1/7. Oh, 7 over 1. That was hard. What number multiplied by 3, 4 has a product of 1? It's reciprocal. What number multiplied by 4/7 has a product of 1? It's reciprocal. The whole number 5 can be written as a fraction, 5 over 1. Find the reciprocal of 4. Well, if 4 as a fraction is this, what's its reciprocal? 1 over 4. We're going to go to the standard algorithm. Oof, so we are skipping a bunch of pages. Ugh, gross. Page 160. Okay. Standard algorithm. Let's do it. 2 problems. We'll do this problem first. Standard algorithm. Pay attention. This is actually going to be something you'll use for a long time in math. Maybe in real life, but definitely in math. 2 can be written as a fraction as 2 over 1 divided by 2/3. The standard algorithm, meaning the standard way we do this, is we leave the first number the same, then we multiply by the reciprocal. This is the reciprocal. 2, 3. See how we flipped it? Bink. Then you multiply straight across. What's 2 times 3? 6. What's 1 times 2? 2. Then we simplify. What's 6 divided by 2? 3. Is that the answer they got? Sure is. Okay, let's try it again. Whole number. How do we write a whole number as a fraction? Over 1. Then, to divide fractions, you multiply by the reciprocal. Multiply, write it, by the oh man, am I going to forget how to spell that? Yep. Let's make it up. Reciprocal. Reciprocal? I don't know. It's close to that. Leave the first number the same. Then you just multiply straight across. That's how you multiply fractions. 4 times 5, 20. 1 times 2, 2. 20 divided by 2, 10. 4 divided by 2/5 is 10. Standard algorithm. We're going to skip all of the drawing. Okay, I'm on page 162. Morgan has a 9-foot long piece of wood that he wants to cut to build some 5/6 foot long shelves. Dude, who has 5/6 foot long shelves? That seems crazy, but whatever. This is a crazy problem. So we need to take the 9-foot piece and divide it by this size to figure out how many pieces he'll have, okay? Which will tell us how many shelves. Blank shelves is the answer we're going for. So we got to take the 9, divide it by 5/6, okay? How do we write a whole number as a fraction? 9/1. Then Miss D says multiply by the reciprocal. Okay, and then we multiply straight across. 9 times 6, 54. 1 times 5, 5. When we divide, we get 10 and 4/5. So how many shelves can he get? 10. He can't have 4/5 of a shelf. This one's going to be garbage. Garbage. But he can get 10 shelves. Reason it's going to be garbage is because every time he cuts, he's got to also take away the width of the blade. That's a little complicated, but that's real life. Okay, let's try one more. The table shows the ingredients needed to make 1 batch of fudge. A cook has 5 cups of evaporated milk. She made the greatest number of whole batches possible. How much evaporated milk remained? Oh, it's a fun problem. Okay, whole batches. How many whole batches can she make? Well, she has 5 cups. So if we take our 5 cups and we divide it by 3/4 cup needed, we'll end up with a number of batches that she can make. Okay, and then we can get out to how much is left over. So let's do this. Okay, to divide, leave the first number the same, multiply by the reciprocal. 5 times 4 is 20. 1 times 3 is 3. 20 divided by 3 is 6, and 2 left over. She can make 6 batches. Okay, now here comes the long part, because they want to know how much evaporated milk remained. 6 batches times 3/4 needed for each batch. 6 times 3 is 18. 1 times 4 is 4. 18 divided by 4 is 4 1/2. And she had 5. Let's see. Better label it. 4 1/2. Oh, whoops. Used. So now we can take our 5 minus 4 1/2. And we can get 1/2 cup remains. All right. You should have enough for your work now. Good luck.